Math with Oscar class. That's my dad.
So far, we've mostly been looking at drawing one-step equations. What we're going to start to look at now is using these pictures of balances to represent solving multi-step equations. These are equations that can take 2, 3, or even 5 or more steps in order to get from the beginning to the end. Remember, our goal in algebra is always to find out what number we would substitute in for our x that's going to make the entire equation true. So, let's start with this problem first. Remember, our goal is to solve multi-step equations. And to achieve this goal, we're going to use visuals to take the abstract algebra and make it as concrete as possible. I also know for many of us this will seem like a little bit of extra work. It's already frustrating to have to write our steps out in English, but then to have to do the pictures as well. But we're going to use these illustrations as another tool to show how the abstract algebra becomes something concrete that we can visualize. We'll start off with 3x plus 5 equals 11. I'm going to start by drawing a quick sketch of what this would look like as a balanced set of scales. On the left side of the scales, I have 3 boxes and 5 more. So here are my 3 boxes of x. Sitting there on the scale. Then I'm going to add 5 pluses because it's plus 5. So 1, 2, 3, 4, 5 pluses. Now, on the opposite side of the scale, I have 11. So what I'm going to do is I'm going to put 11 plus signs over here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I'm going to put a plus sign in each of these to show that they're positives. As we do more with signed numbers, this becomes something that can be very confusing. So I want to stay consistent. Pluses represent positive numbers, minuses represent negative numbers. Now, algebraically, I look at this, and the question usually comes down to what do I deal with first? The 5 or the 3? When I look at my balance, if I want to try and figure out how much will balance on the scale when there's only one box on one side, I can see that I'm going to have to remove some of these tokens before I can start dividing numbers out. I also see that simply removing 3 tokens from each side isn't going to really help me very much. It's not going to deal with this because this isn't 3 tokens. This is 3 boxes full of tokens. So I'll take these 5 tokens off this side and 5 tokens off this side by subtracting 5 from both sides of the equation. This leaves me 3x on the left side and 6 on the right. What did I do to get to this? I subtracted 5 from each side. Now I want to draw a sketch of this current equation. Because remember, our goal is to continue to use visual aids to see what it is I'm solving. If I haven't got it isolated to x equals a number, I need to draw another picture. So, I'm going to have 3 boxes on this side of the scale and 6 tokens on that side of the scale. And they're still currently balanced. As I look above, I can see where I've taken 5 away, and I'm continuing to keep this equation balanced. My next step is going to be to divide both sides by 3. So if I write out what I've done, I have divided each side by 3. In English, that's what I would describe the step as. Now I can go ahead and draw my final answer, which is I cut the amount of stuff on this side in 1/3. So I divide by 3. 3 boxes becomes 1 box. And I cut the number of boxes, the number of tokens over here down by a third. So 6 becomes 2. And now I can see that I've balanced my equation again. The last thing I need to do is check my answer. I'll put the 2 back in the original equation. Six plus 5 gives me 11. That does equal 11. It checks out. So, because when x is equal to 2, the equation 3x plus 5 equals 11 is true. Now I know that I have the correct value to plug in back here. Remember, our goal was to solve this using a combination of algebra, to write out in English what each step was, and then to visually show the process as we work our way down.